All right, so warm-up number 38, given 3, 5, 1, 4, and 1, compute the measures of central tendency and standard deviation, and draw your bell curve, yes? All right. Let's see, just for the sake of getting some answers, measures of central tendency. Get us started, please. My goodness. Had a lot of people come in and, Mr. Good, can you print for me? I'm like, oh my goodness. Let's see. Get us started, please. How you doing? Who? A yardstick? Yeah. Yeah. Andres, get us started, please. Mean. Which is 2.8. Hands, have you got that? All right. Pass someone. Alexa, median. Three. Hands, have you got that? That's about right. Pass someone. Oh, bam. 1. Hands, have you got that? Yeah? All right, so I can pass it to someone. I need the standard deviation since we already have the mean. Standard deviation, Cheney. What'd you get, Cheney? Standard 1.6? 1.6. Hands, have you got that? Looks about right. And then your sketches, yes? Yes, Mr. Q. All right. Agenda for today, warm-up number 38. We're done. We're moving on to another type of measures. They're known as measures of variation. Measures of variation. Measures of variation. Today I'm only doing an intro, and it's not quite just an intro. It's more like going a little bit deeper in regards to something we've been doing already the whole year. And as you know, I give you plenty of practice before we get to the main lesson just so that it rolls a lot smoother. And you're going to see what we're talking about in regards to the measures of variation. And we got home plate page 143, numbers 1 through 8 evens. 1 through 8 evens. All right. We good? Yes, Mr. Q. So yesterday's home play was Act Like Tomatoes. Everybody did? Yeah? All right. And once again, tonight's 143, numbers 1 through 8 evens. All right, get a Cornell note ready. You do need a prayer model. Get that set up, please. And our objective for today, I can summarize data and compute the measures of variation. Measures of variation. You're like, oh, that's new. Yeah, I know, right? All your educational career terms till now you've been hearing about measures of central tendency, and now we're going to switch it up a little bit, yeah? Yes, Mr. Q. All right. So main idea for today, main concept. Tell your neighbor the main concept for today, main concept. Yeah, measures of variation, yes. Once again, we're going to summarize and compute. Summarize and compute. Now, I hope my presentation is working well. Earlier, I don't know what happened. Had the computer just did whatever it wanted to do, I don't know, and then it kicked me out. I was like, what? Really? So I turned it off. How about that? Anyways, rebooted it, and hopefully it's going to work well, yeah? So, measures of variation, what are they? Measures of variation, they're commonly used measures of variance for a set of numerical data that represents the spread of a data set. You're like, man, that's a lot of information, Mr. Q. Once again, measures of variation, commonly used measures of variance, meaning how things might vary from one side to the next, for a set of numerical data that represent the spread of the data. Once again, notice variance and spread, how data is spread. Now, no longer in the center. That's why we're not looking at measures of central tendency. We're looking how it's what? Spread out or spread through. Now let's see. What was the first one? We've already been working with it. Let's see. Can you hear the first one, please? Everyone, what's the first one? What does the R stand for? Range, yes. Now, I hope it's becoming a little bit more clear. That's why we don't mention range in the measures of central tendency, even though we did do it. But if you notice on the Frayer model, we didn't include it as an example, okay? So the range, yes, that's the first one. Another one that we've already been working with is this one. Tell your neighbor what that is, please. Tell your neighbor what that is, please. Yeah, standard deviation. Write that in there. And you can write a bell curve or whatever just so you can have an example. And here's a third one. There's a third one, most common use measures of variance. There it is. Now, it's not new. We've been doing it already. But today we're going to solidize it with a formula just so that you see, oh, you're like, oh, okay, I get it, in regards to what we've been doing so far up to right now. And let's add some meat to this. Give me a second. So we got what? Range, standard deviation, and this one is known as the variance. Variance. And we've been doing all of them, by the way. We've been using all of them. All right? Non-example. What do you think I would use for a non-example? Yeah. Measure central tendency. Mean, median, mode. I mean, we've already covered that and hammered that pretty well, yes? All right? So questions. What makes a measure of variation a measure of variation? What do you think? Tell your neighbor a hashtag. What do you write as a hashtag? Hashtag what? Measure of variation. Hashtag what? JC, go.
Hashtag
range, okay. Man, that went deep right there. Another one, hashtag what? Pass someone, JC. Jet. Bam. Spread, yes, how the data is spread from the center. Very good. Is that it? We need one more, or are we good? One more, Jet, pass someone. Variance, okay. All right. All right, here we go. So I just saw on my other screen that my presentation didn't come out the way I thought it would. Here goes the next screen. Write this down underneath your Frayer model. Data measures. So I'm going to write this in a oval, nice and neat like mine. And one that we really put to rest already, the first measure, or the data measure that we used were what? Central tendency. So we're done with this, yes? And underneath you can write the three of them. And say your neighbor what the three are, please. The second one. Measures of variation. Tell your neighbor the three measures of variation. Three measures of variation. So measures of variation are the range, standard deviation, and variance. All right, and the last one that we're going to cover, not today, but where we're heading, is measures of position. And that one, I'm not going to give you the ones that we're going to use, just so that we can fill that in when we get to that. But this is where we're at. That's the road work where we're going. Yeah? Is that pretty good? Yeah? Yes, I think you. All right, good. All right. So we already covered some formulas. Is that correct? Today we're going to add a couple more, but for right now, that's what we have so far. Yes? All right. So before I move on, check with your neighbor and let them know the formula for the mean for the population and mean for the sample. Sample mean, population mean. Sample mean, population mean. All right, formula for the population mean. Who went last? Aaron, pass someone. Eric, population mean. Mu, that is correct. And then the formula is the sum of all x's and then divided by the total number of items. Yes? This is the formula. This is explaining it, but this is the formula. Yes? All right. Once again, population, and this is for the sample. Okay? Now, once again, don't get confused. We're just doing the same thing, but for two different groups, for the overall group and for a smaller sample group. That's why we need two different types of variables. That's why we use mu for the population and x bar for the sample. Okay? All right. With that said, y'all ready? Copy this, please. Example Q. And it reads, compute the measures of variation for 17365. We're going to do this one together one more time, just to make sure we got it. So, compute the measures of variation for 17365. So, turn to your neighbor, let them know the very easiest measure of variation that you should do right away. What's the easiest one? All right. So, Eric, pass someone. Patricia, the easiest one is the easiest measure of variation that you should do for that data right away. The range, that is correct. So therefore, the range is, help me out, Patricia, go. What do I write? So we got the range, which is 6. Have we been doing range already? Yes, okay. What is the second measure that we're going to do? Pass someone, Patricia? Jet, which is the next measure? Let's go. Let's go. So, check this out. Let's keep organized. So, follow my lead, please. Sketch a column, and we're going to write X, which are what? 1, 3, 5, 6, and 7. All right? So, let's assume that this is population. Tell your neighbor what we're going to find first. Tell your neighbor what we're going to find first, please. Everyone? Mu, yes. Yes, mu. So find mu, which is the mean for the population. Is everybody okay? Yeah? You guys want some coffee or something? Yeah? All right. So 7 plus 3, 10, 11, 21, 22. So we got 22 divided by 1, 2, 3, 4, 5. Is that 5? All right. So what's 22 divided by 5? 4.4. Okay. So far so good, yes? All right. So your neighbor, what goes on the next column? Let's see if they remember the next column. What is the next thing we did? And now don't tell me you don't remember, because we've been doing this almost every day. So what are we doing? Who went last? Jet? Pass someone? Patricia, what are we doing? What's the next thing? We're going to subtract what? Minus mu. Let's go, Patricia in the house. So we got 1, 3, 5, 6, and 7. Minus, 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 minus. 4.4, 4.4, 4.4, 4.4, 4.4. All right. So get your calculators ready, please, so you guys can help me with that part. All right. So tell me what to write next. Patricia, pass someone. Who's that? Amy, what do I do next? What are we doing next? Close. Let's see. Subtract it. So this is what? Negative 0.6. 1.6. Okay. So far so good, yes? All right. But at this step, now that we have that, we have to do what to this? What is it? Square it. Okay, so therefore, what would we write on that column for what we're going to do? Tell your neighbor, what would we write on the column at the top for what we're going to do? I heard something squared. Yes, that is correct. What goes inside that something? Yeah, x minus mu. Write that in there, please. Now we're starting to put the pieces together, because that's building up to a formula that we need, okay? So, square this, square this, square this, square this, square that, okay? All right, Amy, pass someone? Who? Oh. Negative 3.4 squared, what'd you get? 11.56? 11.56? 1.96? Hands if you got up to right there. Okay, so far so good. Then what do? Add them all together. Okay, so let's do the add them all together first. So to add them all together, tell your neighbor what we would write right here for that motion right there. Add them all together. What symbol? What symbol do we usually use when adding all together? Talk to your neighbor. What symbol do we use? Yeah, so we use the symbol sigma. And of course we write parentheses x minus mu squared. And notice we're starting to build up that formula. Notice how the formula is building up. Look up. Goes from here to here to here to there. Are we there so far? Yes. All right, so let's find the sum. Who's got the sum already for this without the division? Maddie? What is it? 23, Michael Jordan. 0.2? 0.2. Hands, have you got that so far? All right. Okay, not bad. How are we doing? Good? All right. So, what did we do next after that? Divide by what? By 5? Okay. So that means, watch, I'm going to write it over here. I need to divide this by 5, which is 23.2 divided by 5. Okay? So this is building up. So check this out. We went from here to here, from here to here, from here to here. Now we need to add more to that. But it needs to apply to any data instead of just 5. Talk to your neighbor, let them know what to write for that next part, All right, let's see. I think we got this. Let's see. I'll get you started. The sum of x minus mu squared divided by, this is the debating part. Yes? Let's say it's a population. Divided by what? Tell your neighbor, please. What is it? Capital N. Let's go. Yes? So far so good? All right, so then we got that. Who's got this, please? Mel, go. 4.64. Hands, have you got that? Okay. So, what do we do next? What is it? Square root. So, what would be the last formula? Square root of the sum of x minus mu squared over n. And that's how we get the formula that you're going to write down. Yes? Now, what do we call this, guys? Everyone? Standard deviation, yes? So what was this before we took the square root? Tell your neighbor, what goes here? No, don't give me numbers. Here's the symbol. This is standard deviation. What do I write for this one? I think Lynn's got it. Very good. Val's got it. Let's go. Marco, you got it? Yeah. Nico, yeah. Maddie, you got it? What do I write here? Which is standard deviation squared, known as the variance. Write that down, please. This is the variance. This is the standard deviation. And if you notice, we've already been doing all the components. So what are the three parts of measure variation? Well, the first part is what? The range. The second part, variance. And the last part, standard deviation. So just so that we can solidify this with our formula, write this formula down for your formula sheet that you already have. So variance is, who can give me the formula? Go. Sigma times x minus mu squared over n. Yes, very good. Tell your neighbor the formula for the standard deviation, please. Standard deviation. Wow. Yeah, as our colleague said, the same thing, but square root. Wow. Square root of the sum of x minus mu squared over n. All right, from 1 to 5, how comfortable are you with all three? Range, variance, standard deviation, 4, 4, 4, 4, 5, okay? All right, now, just to give you a heads up, these formulas are going to continue to be added onto your formulas. We're going to use them because some data that we're going to be covering, sometimes it's a little bit too much. We just need to input values in there so we can compute the stuff, okay? So, variance, standard deviation. So far so good, yes? All right. So with your neighbor or your teammate, here it goes. Ready? Copy this one. Example, supercube. Just copy the table. Tell your neighbor which one you're going to do, brand A or brand B. Paper, rock, scissors, or just choose something. All right, and it reads, compute the measure of variation. A testing lab wishes to test 2 experimental brands of outdoor paint to see how long each will last before fading. The testing lab makes 6 gallons of each paint to test. Since different chemical agents are added to each group and only 6 cans are involved, these 2 groups constitute 2 small populations. The results in months are shown. So there you go. That's the data. Find the measure variation for each one. Sketch your bell curve and find out what you see from there. Compare both paints. I'm going to stop the video at this point. I'll give you some time to do some computation. Go.